Guys, it's hard to believe it's been 2 years since last time I uploaded a video talking about machine learning with Java. Feel free to check out the video by clicking the link on the top right corner and check out what the video talks about. This is a video talking about the brief introduction of machine learning and how to do the job with Java programming language. That video also gives you a very classic example of classifier problem solving. So today I'd like to continue to introduce deep learning with Java. As you see here, I slightly changed the name of the series or the topic, as the open source project used in my video is called Deep Learning for J, so it's a better match. Deep Learning for J is an open source framework for deep learning purpose, which is also commercial grade, production ready framework. So feel free to check it out. What I'm going to talk about today is regression. So what is regression? It is a supervised machine learning technique which is used to predict continuous values. Typically, in a regression problem, the aim is to predict the output of a continuous value, like a price or a probability. Let me give you a quick example. Assuming that you are a real estate salesperson, you like to give the customers better service by giving them a better estimated deal price. What you can do is to collect the prices from the deals made in past couple years. Based on those prices and the specs of the properties done in the deal, you collect them and train a model with them as the training data set, so that the model can expect or estimate based on your input of the property to be sold. The input should be the spec of the property, and then the model will give you the output, which is a type of continuous value. So this is where we can use regression and what the regression problem is. Now I will show you a very classic regression example that is used by quite many mainstream deep learning courses and frameworks. So this is the example. This is to predict or estimate the fuel efficiency based on the car's spec or specification. First of all, I'd like to show you the data I collected. So this data is from a public dataset. This is called the Auto MPG datasheet. It's from the University of California website. So it's used by many examples. What I'm showing you here is the original. So this is the original data set I download, and this is the one I'm used in my example. So this one. The difference is that we can see in the original version, both of them are in CSV format. So the original version has the variant length of spaces between the columns. What I did was replacing those spaces by a single space, so that we can use a space as the CSV delimiter in the record or data reader. it makes data loading easier. Okay, so this is data preparation. The idea is that I want to use data to train a model so that when I enter the car specification, the model can give me the estimation of the fuel consumption. Okay, what are these columns? Now let's look into our code. I will show you in a presentation mode. It's more friendly. Now let's see, let's scroll down here. Actually, let me start from the beginning. Before we train the model, we need to set up and prepare the parameters for the model. The batch size is how many entries in each data set we expect. Now if we see the data sheet, we have about 392 entries. So I set the batch size to 400, which means in each batch there will be no more than 400. Our data will be included in one batch, so all the data will be loaded in the batch and get it fit to the model. And the epochs, this is how many times the model will be trained with the training data set. The seed, this is a parameter required by the neural network configuration. So I'm not going to talk about the meaning of this parameter and how to properly choose a seed. It's the same learning rate. This is not to be explained, but we set it to 0.001. The number of inputs, we have 9 inputs, which means we have 9 features. Output, a single output, which is the fuel consumption estimation or the label. So we have only one label in the data set. So 9 features, 1 label in the data set. So this is our settings. Now let's move on. We need to get the training data set and the test data set. We have the function called get split test and train with batch size. First of all, we are going to load the CSV data set or the data file. You can see here we are using CSV record reader and the file split to initialize the CSV record reader. The data is loaded from this file auto-mpg.data. Now it's time to look into the real data set. Here I have a comment here, the headers. These are the headers of the columns. So first column is mpg, miles per gallon. So this is fuel consumption or fuel efficiency. This is a label. And the rest of the columns, except the last one, model name, are the features. We have features: cylinders, displacement, horsepower, weight, acceleration, model year, and the origin. So I mean features because these are the factors of the fuel efficiency. Model name, not. So I will remove it, but it's part of the original data set. You can see 1, 2, 3, 4, 5, 6, 7. So we have 7 features, but the input here I set to 9. Why is that? Why we have 9 input or 9 features? That's because the region. So if you see here this column 1, 3, 2, this column is the origin column. The region means where this car is manufactured or from. I can't remember the exact mapping of these values 1, 2, or 3, but I remember 1 stands for USA, 2 stand for Europe, 3 for Japan. So this is what they stand for. For this column, we are going to use one hot encoding, which means it will map to multiple columns. As it has 3 possible values, so it will be mapped to 3 columns, which means 1 will be mapped to 3 columns or 3 features. It might be 1, it will be 1, 0, 0. 2 maps to 0, 1, 0. 3 maps to 0, 0, 1. So this is what we call one hot encoding. So if you are not familiar with this concept, feel free to search online and get some sense of the meaning of one hot encoding. So this is the region column. As we have 3 possible values, so one feature maps to 3 features. So after the encoding, we have 2 more features. So 7 plus 2, we have 9 inputs. So that's why we set the number of inputs to 9. This is the data load. The next step is to build a schema. Schema is used to build a transform process. As part of the process, we need to do the one hot encoding. I will show you shortly. So firstly, to build a schema. Schema is how the schema of your original data. So this is a function method implementation. It simply build a schema by the builder. So we add all the columns in sequence, MPG, cylinders, and the rest of the columns, including the model name, which is not really needed by the model. This is the original schema, so you can add it. We will remove it in the transformation process. This is to tell what the schema is of our raw data or original data. Remember to use the correct column type to add them. Now we have the schema. Schema tells us what our raw data looks like. Once we have a schema, we can build a transformation process. We did 2 things in the transformation. Firstly, we remove columns by column name. So we remove column model name, which is not needed in the training. And one hot encoding on the integer column or feature or region. We specify the main value 1, max value 3, which means the possible values of the column are 1, 2, or 3. Now we build a transform process. We have the transform process ready. We can also get a final schema. So this final schema is different as the original schema because we did the one hot encoding in the transformation. You can debug and see what the features and labels are in this schema. Once we have the transform process, we are able to create a training iterator or the record iterator by the CSV record recorder and record reader and the transform process. This is to build the record reader with transform process, and then we use this new record reader to build the record reader dataset iterator. This is how we read record from the data source using the schema and the transformed schema. And we set a regression on the column. The column is identified by index if you look into a regression function. So it requires label index. So we need to tell the index of the column, which is the label. So our label is MPG, so we need to get index of column MPG. we need to use the final schema. So this is how we get the index of the label column. And a build, now we have the train iterator. I just said in the very beginning, we have the batch size. Now when we call next method on the train iterator, this iterator, the record reader dataset iterator, when we call the method next, we get a batch. As we set the batch size to 400, so in one call we get all the data. So all the data is returned, and we have the data set with all the data loaded from the CSV. The next important step is to normalize the data set. Let's see. In the normalization, there are multiple ways or methods supported by the DL4J framework, but we are using normalizer, a standardization normalizer. So this is how we can use it. Initialize, we fit the normalizer with the data set and call the transform method to get the data transformed. You can also debug here and see what the data set has been transformed after the transform method call. Once the data set is normalized, we can shuffle the data set and split into testing and training data sets with a fraction value. We set to 0.65, which means the model will use 65% of data for training, and the 35% of the dataset, the rest of the dataset will be used as a testing dataset for validation purpose. Now we have the split train and the data object, which is used here. So we have the variable. We can use get train and get test methods to get a training dataset and the testing. As we have the dataset ready, we can build the neural network configuration for the network. So firstly, we need to have the configuration. Then we are able to build a multi-layer network. In build multi-layer configuration method, we use the seed, learning rate, number of inputs, and number of outputs to build the configuration. We are using optimization algorithm SGD with the seed and the weight initializer Xavier, and updater L2 set up with learning rate and 0.9 as momentum. We get a list of layers and we can add layers to it. First layer accepts the number of inputs or the number of neurons, which is 9 in my case. The output we set to 64 neurons. You can also give a try and use different number of neurons in your intermediate layers and see how it performs. But in my case, I set to 64. Okay, you can see in the following layer, which is a hidden layer, it's using the same input and output, or same input number of input neurons and output neurons, it's the same. And see here the activation method in the first two, or the hidden layer and the first layer. We are using the RELU, which is a rectified linear unit function. The last layer, this is the output layer. We are using loss function MSE, so the main square area with activation function identity. The input is the number of input is the number of output of the hidden layer which is 64, so 64 neurons. The output, there will be only single output, so this is the number of the labels, which is 1 in our case. Now we have the configuration built. Once we have the configuration, we can build a multi-layer network. Using the configuration, we can initialize the multi-layer network. I also set the listeners here to the network, which is a score iteration listener. This listener gives us ability to print or display the score of the iterations. The parameter 1 means that in each iteration, we will print the score. You can also specify, say, 100, which means you will only see the score in every 100 iterations. Now we have the network ready for training. Here we are going to use a for loop to train the network or fit the training data set to network multiple times. How many times? It's specified by the epochs. So it's determined by the epochs. Once it's trained, we can use a testing dataset to do the regression evaluation. Here we use the regression evaluation class to do the job. We make the function output function or method call to the network with the test dataset. We just use the features in the test dataset. And in the output method call, we also set the second parameter to false, which means this is not for training, this is for evaluation or testing. So or prediction. So we have the output. Now it's time to use the eval method to evaluate with the labels in the test dataset and the predicted output. There are multiple metrics from the evaluation variable or the object that can be used to evaluate the performance of the model. Typically, we are looking into the MSE, MAE, the RMSE, and the RSE. So feel free to check out these metrics and see how it tells the performance of the model. Now let me run the application. You can see what it does. Now you can see this is what I mentioned, the score in each iteration. So in each iteration, you can see the score is getting lower or smaller. Initially, it's pretty big. And you can see after about 600 or 800 or even after 1,000 iterations, you can see the score tend to be stable, not much decrease on the score. So I set to 2,000, so there are 2,000 iterations. The score stay around 1.8 or 1.7 at the end. So this is the score at each iteration. It tends to be stable at the last 100 or 2 iterations, and the metrics displayed here. Now you need to use these metrics to evaluate the performance of the model. Maybe it's not what you expect, so you need to see if this is a valid model, if it's a valid data set for training. You may need to choose different features, or you may need to use different normalization method, or even change the neural network configuration. So The next step is to optimization and prove this is the correct idea, this is the correct method, the correct feature data set or training data set you should use. Sometimes you are not having a correct idea or correct data set for training, and the model won't fit your requirement or expectation. That happens in deep learning. Okay, hope you get the idea on the regression and how to use deep learning for GA to set up the model and train it. Okay, I think that's it for today. I will also submit the code to some GitHub repo and share it in the video description. Feel free to check out below. If you feel it's interested and helpful, remember to thumbs up, subscribe channel, and ring that bell. Okay, see you next time. Thank you. Again, before I finish, I like to say Java is still important in machine learning and deep learning. If you are familiar with Java or a pretty senior Java developer, you like to get involved in deep learning, you should check out the open source framework Deep Learning for J. It might be a good candidate for your job. Okay, that's it for today. Thank you for watching. See you next time. Bye bye.